All right, next one. How many ways, so we've got 12 runners, how many ways can first, second, and third place occur? So this one's different than the one just a second ago we considered, because now we're just doing first, second, and third place, so how many blanks? Just 3 blanks, right? I'm not going to do all places, I'm just going to do first, second, and third. So I need just 3 blanks here, first, second, and third. Blank for it. All right, well, how many possibilities are there for the first blank? Well, again, starting off, any of the 12 could win the race, so we've got 12 possibilities for first place, right? However, going to second place, whoever does first place can't do second place as well, so we lose 1 there to 11, and then third place, 10. So is this a factorial? It's not a full factorial, is it? Because to be a full factorial, it has to go 12 down to 1. So this one's not 12 factorial. So at this point, all we can say is we're just going to have to punch that in. 12 times 10, 11 times 10, multiply those 3 together, which is a perfectly fine way to do this. However, let's notice something about this one. All right. So on your calculator, if you got your calculator handy there, look for an NPR button or a PNR, or it could be like this. See if you have one of those buttons. On mine, the TI-30 here, it's mine's above the 9, number 9. Or it might be on a PRB. If you go to PRB, again, you have that button. Look for that. If you have trouble, just let me know. We'll try to find it. Okay, so here's what I want you to do. Type in 12, and then hit the NPR button, however you do it, and then hit 3. So 12, and some of them may also do it a different way too, so if you have trouble, just let me know. 12, and then the NPR, and then 3, and then equals. What do you get? 1,320, yeah. Again, that's not by coincidence. What this is known as, the P stands for permutation. This is what's called a permutation. And like the factorial, the permutation is a countdown product, but it may be only a partial countdown product. You see what I'm saying? So I do have a countdown, 12, 11, 10, but it's only a partial countdown. Partial countdown. And so notice I've put in some different numbers. I put in the 12, you probably get that, but why the 3? Well, let me just give you the definition. All right, so NPR or PNR, P parentheses N, R, I think that's the way the book typically writes it. Or it could be P and then the N and the R kind of side to the side like that. Any of those is what's known as a permutation of n things taken R at a time. So the n is the number of things you have, which in this case we've got 12 runners. And then the R is how many you're doing at a time. So in this case we're doing 3 at a time, aren't we? 3 places. So if I was writing them out, I'd have 3 at a time, A, B, C. You know what I'm saying? So that's why I did 12 NPR3 here. Okay, so punch in P20, 6. See what you get there. P20, 6. So first number is 20. hit the NPR button, and then hit the 6, and then hit equals. Ooh, bunch. 27,907,200. 27,907,200. That's what I get. Anybody else get that? NPR? Now, that's good if you can punch it in. That's one step. However, what product is this? I didn't. So understanding what that represents is important too. So what product would that be? Well, it's a partial countdown. Where do I start? Start at 20, count down, 19, 18. Now, how many do I write out? I don't go down till 6. I write it out until I have 6 numbers. You see what I'm saying? Just like here, this one didn't go from 12 to 3. It just went to 10 because there's three numbers there. So we start at 20. And then write out 6 numbers. You with me? So where do I go down to? 17, 16, 15. Stop there, right? 6 numbers. So that's important too to understand what you're calculating there, because you can go back and forth. Now, let me do one more, I think. I think it'll do what I want it to do. Yeah. All right, let's do one more of those just because here's what else can happen. All right, so let's say we do P35,7. P35,7. So let's write out the product and then evaluate. Because that may be how on the test I write that. Let's call them out. All right, so if I, well, let's just talk about, let's write out the product. So if I write out the product here, what is that going to be?
35 times 34.
35, 34, till what? 33, 32, till I have 7 numbers? So I need 3 more, 31, 30, 29. Okay? Start at 35, get 7 numbers. Now, evaluating that, all right, so you go 35, NPR, 7. So my calculator, yours may show it something different, but it has a decimal number, and then it has a little number there. Anybody know what that means?
Too many numbers for the calculator.
Too many, yeah. It's way too big for this to display. So what this is the calculator's version of scientific notation. So that's not how I'd want the answer written. Scientific notation remember what it looks like, it's supposed to look like? And some calculators do a better job at displaying it. This means 3.3891508 times, and that's the power of 10. That, maybe this isn't the best example because the power is 10, but this is the power of 10 that I want. Or another way to look at it, this says move the decimal place 10 places this way, right? If it was a negative, you move it the other way. But so it's a large number. It's this number, but move the decimal place 10 places that way. So I'm only displaying 1, 2, 3, 4, 5, 6, 7, 8. So I'd need to move it 2 more places. I don't even know what those numbers are, but if you don't know, I'll put in zeros. But this is a large number, okay? So this right here is the answer. Don't really put put it in the scientific notation, because that looks like it's that to the 10th power, which is, it's that times 10 to the 10th power. All right? Okay. Now, one thing to point out here, let's try to think of another problem here real quick. So again, in a race with 20 runners, how many ways can first through fifth occur? In a race with 20 runners, how many ways can first through fifth occur? Well, you got 5 places, so 5 blanks. All right. First place, any of the 20. Second place, can't repeat, so it's 19. And then no repeating, so down to 60. So this is one way to do that. 20 times 19 times 18 times 17 times 16. No problem. I can get that answer. 18,604,008. Oh, sorry. How about that? 1,860,408. Okay. Now, does anybody see another way we could do this without having to punch in all the numbers? That's a permutation, isn't it? What is it? It's a permutation of 20. Choose how many at a time? 1, 2, 3, 4, 5. And that'll get that same number. Right? It's permutation. Now, did I have to write it as a permutation? No. I didn't have to write it as a permutation. I could have, but this was just fine. Just like on the factorials. You don't have to use the factorial button. You can just multiply whatever the numbers are out. Okay? So, do you need to know that it's a permutation? Yeah. Maybe not. Just be able to get these numbers, so either way is fine. Now, we're going to look at something next where you will have to recognize it, so we'll talk about that. Any questions, though, on